Daniela, so nice to spend some time with you here at UC Davis. Just give us a little background as to what you do on this beautiful campus. I know you're heavy into research around oligosaccharides, polyphenols. What's the day in the life of Daniela Barile?
We have set up an analytical lab, which is equipped with fancy mass spectrometry equipment, which are big machines that can measure small molecules, even when the small molecules are very low abundant in food. And we like to do this because some of the small molecules are very important for health.
So how does that translate from food sciences to the application of, human health when we're talking about small molecules? What would be some examples?
Yeah, we work with the food industry and they really keep us on our toes to be focused on things that are translatable, not just me looking for this tiny molecule in this place that doesn't exist, right? So we work on things like milk and dairy streams, coffee and spent grounds, and then most recently grape pomace or grape marc, and which is a byproduct of the wine industry, and it's very important for health. So examples like that, or like even beans and the aquafaba, which is the water that remains in the can.
Right.
What do the consumer do? They toss it down the sink. We found
Highly nutritious.
plenty of small molecules that are important for health, specifically for gut health.
Very, very interesting. Well, you open up a can of worms there for me, but I'm going to pull you back to one of the first things you said, and that was milk. Mother's milk in particular. So I'm familiar with some of your research. Intriguingly, it connects mother's milk and wine. So that's where I want to start with you, especially Coastal Chardonnay marc in context of health. So share with us, if you can, this aha moment that led you to explore this maybe unexpected connection.
Yeah, so we started from human milk, and there's actually a milk bioactive program here at UC Davis where unexpected professors are working on it. Engineers, not only clinicians, gastroenterologists, chemists. So many people get together to study breast milk because the composition is so complicated. You need to decode it, and then you need to understand the function. So we also have a lab, which is a pilot plant, where we literally take milk apart, molecule after molecule, and then we test it. We test it with bacteria, we test it with mice, we test it with piglets, and that way we can understand the function of each molecule. Human milk is unique because it's evolved over millennia, and we know evolution, nothing is free. Right. So if the molecules are still there, this small molecule called oligosaccharides, they must be important. And so we found that they are really selective in feeding only the good bacteria in the baby microbiome. So they really set up baby for a healthy life.
And one of the most important things that we've learned, and the microbiome is a medical buzz term of the day for a good reason, and we understand that there's implications to all sorts of health, but particularly the infant and the initial stages of life, and getting those nutritional complex carbohydrates, oligosaccharides from mom's milk. Translate this though, if you can, for us, how this might have health implications for adults. I mean, that's really a lot of the research that's you've come to understand, and also the selectiveness, how it's only feeding the good stuff, the good bacteria, and maybe not focused on, or the bad stuff is not eating it.
Exactly. The secret for that is chemistry. Chemistry can solve a lot of problems, right? So with chemistry, we can understand the building blocks of oligosaccharides, and we can understand the linkage, how each building block is assembled. And so that is the secret to make sure that only a few types of bacteria can actually eat it and consume it as energy and then grow and proliferate. And the pathogenic bacteria don't have the enzyme to cleave some of these linkages. So they're staring at this carbon source like, I want to eat it, I can bind to it, but then they're starving out. And so bifidobacteria, for example, are a beneficial type of probiotics, and they evolve with babies to be anti-inflammatory and to keep the gut in a really healthy state.
This sounds very complex. There must have been so many stopgaps or challenges along the way. Obviously, research often comes with its own abundance of challenges, but also breakthroughs. So maybe share a moment during this research on oligosaccharides and also phenolics. I know you're very heavy into phenolics. Bring us through that and maybe the Coastal Chardonnay marc that was particularly challenging or surprising, and how it shaped the course of Daniela Barile's study or research.
So yeah, we work with breast milk, and we get it from donors, but clearly there's not enough to translate to adults. To your point of earlier, that adults would also benefit from these type of molecules to guide the microbiome, because so many people right now are suffering without even knowing it from dysbiosis, which means you have too many undesirable bacteria and not enough good anti-inflammatory bacteria. So we end up having a chronic inflammatory state, and then we know the gut-brain axis is important, so we even get brain inflammation. We don't even know it. So adults could really benefit from this. Human milk is not enough. Let's save it for premature babies that really need it. Now we study the composition. Fantastic, life-saving. So to translate it, we looked in different foods and food waste. So a few years ago, we published a paper on just studying wine. I'm Italian, so it was a good start to look at white wine and red wine and find something else good besides the phenolic compounds. So we did identify oligosaccharides. And then we got in touch with Sonomaceutical, who's a startup funded by two women in the Sonoma, Napa Valley area. And they approached us because they wanted to study the grape marc, which is the byproduct and is really abundant. And 30% of the grape mass ends up becoming basically an undervalued byproduct. 30%, it's a huge thing, especially for California. And California produces a lot of Chardonnay, so that's why it was logical to start from Chardonnay. By then, we had developed all of the analytical tools with our fancy machine to study oligosaccharides in breast milk and in a few other foods. So the challenge was to adapt those to a completely different matrix, right? So now we're talking about plants, we're talking about seeds and skin, and we were used to work with a nice and soluble liquid. So lots of challenges there. But we were able eventually to adapt our protocol, and we have discovered 40 unique molecules of oligosaccharides in the Chardonnay marc, and that they have 11 building blocks. So that was an aha moment, because it's like, whoa, they're even more diverse than the oligosaccharides in breast milk.
Wow. Okay. Wow. So, and hold me honest here, correct me if I'm wrong, we have a product that's basically otherwise waste stream, and we still get to drink our Chardonnay, but with this product, it's otherwise waste stream, left abundant with these phenolics, oligosaccharides. We've harvested that in an environmentally friendly manner. You've isolated oligosaccharides that are so helpful and healthy for human health that we'd otherwise expect to find in mother's breast milk. Along with these phenolics that are built in within that, we can take this and get healthier. Ultimately, as you mentioned, satisfy the gut-brain axis and the microbiome. Congratulations on that and overcoming those hurdles. We also just spoke off camera a moment ago about TH1, TH2 balance. I think society's faced with a lot of immune dysregulation.
Yes.
And one of the applications of this, maybe off-label, for sure off-label, is immune modulation. Agree or disagree?
Totally agree. It's really important to be able to control it. You want to take control of your gut, like if it's a switch to turn on off the light. I don't want to get traveler's diarrhea. I want to have a supplement off the shelf I can take that's healthy for me, that changes my gut microbiome for this challenging period. But maybe I don't want to change it forever. Maybe I want to go back. Or I'm taking antibiotics. Or I have a procedure at the hospital and I need a particular strength, right, for my immune system, because the gut microbiome is the immune system.
Absolutely. So you mentioned, and this struck me as soon as you said it, you discovered numbers of different, or abundance, additional oligosaccharides that are not otherwise found in human breast milk. Do we know for sure that these are also conferring health benefit?
So the structures are slightly different. Some of the same building blocks are in common, but clearly we're talking about a plant versus the human mammary gland. So I'm not saying they're identical for us was striking after having looked at other foods which did have a simpler composition in oligosaccharides. For example, bovine milk is not as complex in terms of oligosaccharides diversity as the Chardonnay marc is.
Right.
So even though not identical to breast milk, then we have isolated the oligosaccharides at lab scale to separate them from the phenolics, to make sure the contribution we were seeing to the health benefits was really from the oligosaccharides. So doing that in collaboration with microbiologists, we were able to replicate the selectivity we talked about.
Right.
And this comes from the building blocks, the complexity of structure. So even though not identical to human milk, still an incredible potential for selectivity.
As an Italian, you love wine, you admitted it yourself. There's nothing better to pair it with, in my opinion, other than cheese, than a piece of chocolate. So now what's very intriguing, you've had it, I've had it, is this biomass, or otherwise, referring to as Coastal Chardonnay marc, which folks can look at as Wellvine, the actual end product, and can start finding it in some pretty amazing tasting chocolate known as vine to bar, and we both experienced this. What are your imagined implications of these types of healthy finished products that contain these oligosaccharides, that contain these polyphenols, now being able to essentially dose ourselves healthy in a consumable, tasty, and sustainable food product? I mean, what are your thoughts as a scientist? I mean, how this has all come from lab to store?
It's impressive to see the speed, right? The speed at which everything happened. I would never have thought in just a couple of years since starting working with this company that now you can go on Amazon and order this product, which contains our oligosaccharides and the phenolics.
Right.
It's really exciting. I mean, and now we can go on ice cream, on yogurt, on pasta.
I like the sound of that. So with this incredibly complex research that you're involved in, of course, I think you'd be the first to admit, it's never about one person. It's a team effort and a collaboration. Who would you extend kudos to that's out there, maybe even on this university campus, to say this team had to come together to make all this research happen?
Yeah, absolutely. I would say it's the microbiologist. The microbiologists, we wouldn't be able to demonstrate the benefits without them. And they have a lot of patience because when we give them the product that we isolate, often it's not pure. Right. So there's a lot of back and forth and a lot of learning, even the language that the other person is speaking. Chemistry and microbiology, not the same, right? And so at the beginning, we were giving them some powders that we made from the Chardonnay grape marc that contain both oligosaccharides, but also phenolics. And those were ironically not clean enough for them. And the phenolics are so powerful, they have their own effect that can kill bacteria. And so the results were super confusing for all of us until we realized we actually had to develop a lab scale method to separate them, which is not necessary for the final product because in the consumer, you actually have a digestion, you have a gut that takes care of everything, right? But for the lab, there was a lot of patience and understanding from the microbiologist side of you while we figure out the process until we have pure oligosaccharides, prebiotic effect, pure phenolics, more of antimicrobials, suppressing the bad guys. That's why they're so good together. That's why there is this synergy.
And lastly, what are you on to next? What kind of research are you excited about next? Because I know it's always next for you. So what's up next?
We want to make more oligosaccharides. We want to work with the industry to do more scalable process. So far, we have looked at what's naturally existing in the grape marc because there's some enzyme, there's some, it's a natural fermentation process making wine that results in the presence of oligos. But we want to use technology like subcritical water extraction, microwave enzyme extraction. So green technology that are not polluting, that not using chemicals, to break down the cell wall of the polysaccharides and increase the level to make even more, to make it even easier so more people can benefit from more oligosaccharides.
That sounds incredible. Thank you so much for your time with me here today and making this so easy to understand. I appreciate everything you're doing and all this wonderful research, Daniela. Thank you.
Thank you.
Appreciate it.